resume recording. And let's open the whiteboard. All right. And let's do number 34. Maybe. Okay. Okay. So we have 1/2 t squared plus 1/3 equals 5/6 t. All right. What can someone tell me about the numbers 2, 3, and 6?
Is it because they have a least common denominator?
Yep.
Or, yeah.
What number would that be? What number would you like to use?
6.
Very good. So we're going to multiply the whole thing, each piece, by 6. And when we do that, you're going to see something cool happen. So 2 goes into 6 3 times, so we're going to get 3t squared plus 3 goes into 6 twice. And then the 6's cancel, so you get 5t. Now, once you get here, you want to rearrange it so that the 5t's with the other terms. So it's going to be a minus. Okay. So now we can go straight to factoring, but this probably looks a little bit different than any factoring you've done. So typically we would split the t's, right? We are still going to split the t's, but one of your t's will have a 3 with it. Okay, a 3 is not a perfect square, so you can't split it up in any other way but 3 and 1. 2 has how many factors? How many different things that multiply together will get you 2?
Is it just 2?
Yep, 2 and 1. So 2 and 1. Oops, that looks like a V. All right, now the only thing we have left to do is figure out our signs, but the 2 is what? Positive. Okay, so our signs have to be the same, but what do you notice about your 5?
Say negative.
Right, so we're going to have a negative in both spots. So to finish it out, we're just going to set them equal to 0. So t equals 1 or t equals 2/3. If you plug either of those in, you should get true statements. All right. Any other questions on factoring? Any other ones you'd like to see that we didn't do yet?
Can we do 26?
Sure. Give me 1 second. Okay, 26. Ah, yes, I see why. Okay, 26. Okay, so we have n to the 6th minus p to the 6th. First question you want to ask yourself is, do we have an addition or a subtraction? Because when it comes to binomials, if you have an addition, you might not always be able to factor, but with negatives, you almost always can. So what did we do in 25? 25 was a sum of 2 cubes and a difference of two cubes, right? So we're going to split this first, and then you're going to notice something. So when we split this, how are we going to split it up? We have n and n and p and p. What are our variables and what are my signs going to be? Not variables, exponents. What do you guys think?
Would your
Remember-
exponent be a 3?
Yes, absolutely. And what about your signs? Are they going to both be the same? Are you going to have 1 and 1? What are we going to have?
One is going to be positive and one is going to be negative.
Yep. And it honestly doesn't matter which way, but we'll go with that one. Okay, so my next question is, am I finished? If you have your stuff from yesterday, if you have your notes from not yesterday, the day before, if you have those notes, they should look very similar to another couple of numbers we did. What do they look similar to? How would you describe these terms to me? What kind of terms are they? They're what? I think you guys know this. What do you guys think? You can give a guess. If you're wrong, I'll just tell you you are. It's not a big deal.
Variables.
Yes, variables, good idea. Tell me something about these variables. Specifically, check out their exponents.
They're cubic.
Cubic, okay? So on Monday, we did something called the sum of 2 cubes and the difference of 2 cubes. And I told you it kind of works in a nice little pattern, okay? So we're gonna have one binomial and a trinomial, and then we're gonna have a second binomial and a second trinomial. Why? Because we have a sum of 2 cubes and a difference of 2 cubes. Okay, so we'll do the sum first. N plus P, all right? And then it was N squared and then the opposite sign, n times p, same sign, p squared. Okay? That is for this one. Now, if we look at the difference is pretty similar, except we're going to have different signs. So we're going to do n minus p, n squared, plus np, plus p squared. Now that's it. You can't do anything else to it. Those are your statements. You could choose to rearrange those. You would still get the same answers. I would not, because if you leave it the way they are, then you can very easily see where they came from. Okay. What else? What other one would you guys like to see? I will probably try to start working on your review maybe next week. Maybe on Tuesday I'll be able to get it done. As soon as I get the review done, I will email it to you, as well as put it up on Canvas. All right. What about 27? Was anyone able to get 27? I don't think we went over that one yet. Guys are really quiet today. Is it just because it's a Wednesday? I'm gonna assume nobody has questions on this, right? We went through it, okay? What do you guys think? If no one has any other questions on factoring, I'm gonna assume you guys are cool to go with it.
Actually, I have a question. Can we just do 27 then? I'm good then. That one confused me a little bit.
Sure. Okay. So I want you to factor x to the fourth minus 2x cubed plus 1000x. Those are really bad zeros. Sorry, guys. Minus 2000. Okay, so what kind of factoring do you think we might be able to use? Remember that there's a difference, a different technique when we have 4 terms versus 3 terms. So what technique, what factoring
By
technique?
grouping.
Yep. So we're gonna factor by grouping. Okay. So I told you last time that typically it doesn't matter which sets you pull together, but what sets do you think would make sense to put together? What can you easily see that you can pull out? Remember, the goal is to get the parentheses to be the same. So how do you think you want to make your groupings?
x to the fourth and negative 2x cubed, and then 1000x minus 200.
Yep.
2000.
Gotcha. Okay. So now that we did that, someone else tell me, what do you see as common in the first group? What can we pull
The
out?
third. Is it x to the third?
Very good, yes. Okay, so then we get x left minus 2. Now, looking at the x minus 2, we want to get the second parenthesis to be the same. So what can we pull out so that we get it to be the same?
1000.
Mhm. Okay, and now that we have the same parentheses, these are the same, we're only going to write them down once. So x minus 2, and then x cubed plus 1000. Now, here's my question for you. Do you think you're done?
No.
No, because what can you tell me about x cubed plus 1000? What kind of binomial is that? Is there a way to break that down? That should help you. It should look pretty similar to what we just did, because it's what? Addition tells you it's a sum. So it's a sum of two, what? If x cubed is a cube, what can you tell me about 1000?
Would
Is-
it be x plus 10?
That's our first part, so x plus 10. Which means what comes next? Do you remember the pattern?
I believe that's when you're writing like the x squared instead. But I'm not really sure after that.
Okay, so remember it's the first one squared, and then for the sum, you change the sign, then you multiply the two together, so 10x. And then it's plus the second one squared, so 10 squared gives me what?
100.
There we go. Okay, so this entire thing is your answer. Looks a little bit like Christmas. I can tell you that in the past, I have had to give students worksheet after worksheet after worksheet when it comes to factoring. So if you're not getting this on Pearson, you need to keep doing the practice over and over and over and over again. Factoring, like eventually when it clicks, you're going to be able to do almost any factoring problem, but until it clicks for you, it's just got to be practiced over and over and over again. Okay, so that was 27, factoring by grouping. We did 30, So 28 and 29 are up if you want to see either of them. But I think you should be fine with 29. Does anybody brave want to do 28 for us? Or you can just give me another number to do.
What about 23?
We skipped that one yesterday? Okay. No worries. Okay. So we're still factoring 6x cubed y squared plus 26 x squared y cubed plus 24 x y to the fourth. Okay, so yesterday I told you guys that if you can do something, you should always do it first. What do you think it is?
Factor out the GCF.
You want to figure out your greatest common factor. Is there something that goes into all three of these? Is there something that goes into all three of these terms?
Two.
Yep, let's start with the 2. So 2 definitely goes in. What about anything else? Can anything else come with these guys? So the first thing I look at when I do them is I look at the numbers. So that's how you got your 2. The next thing you want to look at is the x's. So we have x cubed, x squared, and x. What is the lowest of that?
Just be x.
And do the same thing for the y. What are we pulling out when it comes to the y?
Y squared.
Okay. So now we got to see what's left. S- 2 goes into 6 how many times?
3.
Okay. Your y squareds cancel. You already pulled it out. So you have x cubed and you took away an x. So how many x's are left?
X squared.
Perfect. All right. Keep it going. 26 divided by 2 is what?
13.
And then x squared divided by x?
X.
And y cubed divided by y squared?
Y.
Okay. We're going to do the same thing for the last part. 24 divided by 2? Almost gave you the answer.
12.
Very good. And y to the fourth divided by y squared?
Y squared.
Excellent. Why did I not ask you x divided by x? Because they
Cancel out.
cancel out, it becomes 1. Very good. Are we done? Is this your final answer?
No.
Very good. No. So we're going to go into 2 parenthesis sets. Now, here's something that's interesting. We have an x squared and we have a y squared. What have we done with that before? We had a problem kind of similar like that on Monday. What did we do with those? We have to what? Well, we said when we were first talking about factoring that the x's don't like to be together, right? Typically. So this x just had a little bit more funding than the other x. That's why it gets to be a 3. So we get 3x and x. All right. So what are we going to do with our y squareds? They have to also be what? Split, right? Okay. So we're going to have a y here. We're going to have a y here. Now, here's the thing. 3 only has 2 factors in it, right? 3 and 1. I can't do anything other than that. So there's my situation there. We know all the signs are going to be the same because we have plus and plus up top. The problem is 12 has how many terms? More than 2, right? It's not just 1 and 12. It's 1 and 12, 2 and 6, and 3 and 4. So we have to figure out which set of factors will help us get 13xy in the middle. Okay? How do you think we can figure that out? Okay, so let's think about it. Let's look at this. We have 12, either 1 and 12, 2 and 6, 3 and 4. And we have to use that in conjunction with this 3x and this x to get us to 13xy. So let's look at it. Right now, if we take 3x times y, we get 3xy. And x and y give us another x and y. So what do we have so far? Three xy and xy will give us how many?
Three?
Remember, there's an imaginary 1 here. So not 3xy, but
4xy.
thank you. Yes, 4xy. Okay. So now what? How does that help us? So I mean, you can play guess and check. That's one option. If we put a 1 in here and a 12 in here, that still gets us 12y squared, right? Yes, it does. Okay. But if we do that, then we're looking at another xy. So then that would give us 5xy. But then what happens? 12 times 3, isn't that going to be way more than 13? Yeah, so it can't be 12 and 1. So what's another option? What else can we put in there?
2 and 6.
Okay, so let's try 2 and 6. All right, so 6 times 3 is going to give us more than 13, right? All right, so we know it's not going to be that way. Could it be another way? Could it be a 2 here and a 6 here? Well, that would give us 6xy. So that gives us 10, but then another 6xy would give us 16. So it can't be that one. So what does that leave us with?
Wouldn't we just use the 3 and 4 from the problem? So it'd be like 3x plus 4, and then just plug in the 3 for the other one.
Sure, we can try that. What does that end up working? Yeah. All right, cool. So can't really, I mean, me doing it when I did it on my paper, I went ahead and just went straight for the 3 and the 4. And then if you check it, it checks. It's just really time. You're not really going to be able to just always know what it is. Sometimes you're going to have to plug things in and play around with it. But the upside is at least you're only working with the factors of the middle term, okay? Or of the last term that gets you in the middle term. So you're not working with every single number in the known universe. All right. That was page 4. Any other questions? Does anyone need to see 31, 32? I think we did 33 yesterday. We just did 34 today. 35 is just plugging in. So that really, you should be fine with that. 36. Did anyone have trouble with 36? Whatever you guys need help with, I'm